Okay, t-test on equality of two slope parameters. So this is the equation. Okay, so let's say I want to know if B3 equals B4. So this is the new hypothesis. Alternative hypothesis would be B3 is not equal to B4. So it implies it must be done as two-sided test. Computer t-stat must be given to you in the formula sheet. So B3 hat minus B4 hat minus bracket B3 minus B4. And then actually, if we want to test if B3 equals B4, then it means the difference between the two would be 0. So this thing would fall away. Divided by this, which is actually equal to this equation, square root of variance of B3 hat, which is actually the standard error of B3 hat squared, plus variance of B4 hat, which actually means standard error of B4 hat squared, minus 2 times the covariance between B3 hat and B4 hat. It must be given to you, the covariance. Okay, so, and then I think in the study guides, there are 2 or 3 examples given to you, and then in order to fully refresh your memory, I'm going to do one question here. This is a multivariate regression, year mark, explained by lecture attendance, tutorial attendance, and whether the student is a male or not. It is a male dummy, so that relates to chapter 9, the dummy variable chapters. And then as I said before, the covariance between B3 hat and B4 hat must be given to you, because in this question we want to test if the parameter of tutorial, which means B3, and the parameter of the male variable B4, are they equal to each other in the PRF? Currently, they are not equal to each other, but in the sample regression function, but quite close actually. Just slightly greater than 1. So this is how we work out the answers. Step 1, I think you should be fine with the new hypothesis and alternative hypothesis. Step 2, computer t-stat, the formula. So B3 hat, which is 1.8745, minus B4 hat, 1.2732, and then minus the bracket. B3 minus B4 should be 0, because this is the focus of the test. So that falls away. Divided by the square root, I think there's an error there. I must extend the square root line actually. So equals to variance of B3 hat, which actually means the square of standard error of B3 hat. This is why I take the square of 1.7334 plus the variance of B4 hat. So variance of B4 hat is actually the square of standard error of B4 hat. This is why I take square of 0.4444. And then minus 2 times the covariance between B3 hat and B4 hat, which is given 2 times 0.1234. We work out the answers, then we take the square root. Okay, and then using your calculator, you should get the final answer of 0.3498. And then the critical t-stats. Sample size is 124. K is equal to 4. You see 4 parameters. So degrees of freedom is 124 n minus k, 4. So it is 120. Alpha is 1%. Two-sided test. So the top row of the t-table gives me half of the alpha. So half a percent. So 0.005. Second row gives me my full alpha, 1%. Degrees of freedom 120, so my critical t-stats are plus or minus 2.617. Remember, this is a two-sided test. You have to add plus or minus. And then since the compute t-stat lies between the two critical t-stats, it means the new hypothesis is not rejected. That it means from a statistical point of view, the new hypothesis is more likely to happen. So step 5, so H0 would take place. That is B3 equals B4 in the PRF. Okay. And then as I mentioned briefly in the table, you must read, in the video, the previous video, you must read the question carefully. Which two slope parameters are the focus? So if it is about equality of B2 and B4, you have to amend the equation like that. And similarly, if the question asked about equality of B2 and B3, you again have to amend the equation slightly as follows. Okay. Then we can move on to the F test. So I'm going to start with the easiest F test. Okay, on the overall significance of multivariate regression. Okay, and then in other words, I want to know for the multivariate regression, would at least one explanatory variable make sense? In other words, I want to see if R squared would be greater than 0. Okay, so and then this is my new hypothesis. New hypothesis means all slope parameters equals 0. Then it actually means this is a bad regression, meaning R squared is 0. Okay. And then the alternative hypothesis means not all slope parameters are simultaneously 0. In other words, at least one slope parameter is non-zero. So it also means R squared is greater than 0. Computed F statistic, the equation is given to you in the formula sheet. It's quite simple. Critical F stat. And then when you look for the degrees of freedoms, there are 2 degrees of freedoms. Degrees of freedoms of numerator is hiding here, k minus 1. Degrees of freedoms of denominator is actually here, m minus k. And then if the computed t stat is greater than critical f stat, sorry. If computed f stat is greater than critical f stat, we reject the null hypothesis, which is good news. So for this type of f test, testing the overall significance of the multivariate regression, our aim is to reject the null hypothesis because we want to see at least one slope parameter being non-zero in the PRF. Okay. And then there are a few examples on the slide. So let's do one question. You see, I show you the equation here for the computed F stat. So this is the regression, sample regression function. Sample size is 20. K is equal to 3, actually. R square is already quite high. I think this regression is quite good because the 2 explanatory variables, study hours x2 and party hours x3, they are relevant to explain variation in students' marks. So test for the overall significance, you spot the keyword overall significance. So then it means the F test. Alpha is 5%, and then let me move to the F table here. I think you should be fine with the first step. And I think you are also fine with the second step substitution. R squared 0.8765 divided by, remember to use bracket, k minus 1, it means 3 minus 1, divided by 1 minus R squared, and then divided by bracket, m minus k. Okay, 20 minus 3. So this is my computed F statistic, 60 point something. Critical F stat, degrees of freedoms of numerator is 2, degrees of freedoms of denominator is 17. 2 and 17, alpha is 5%. So let's look at the F table. 2, 17, we must look for the right alpha, 5%. This is why the critical F stat is 3.59. Yeah, 3.59. Then the computed F stat is way above critical F stat, so we reject the null hypothesis, which is good news. Then it means from a statistical point of view, alternative hypothesis will take place, meaning at least one slope parameter is non-zero in PRF, so it is good news. Okay, happy with this? This is the easiest type of F test out of the 4 F tests we are going to do. And then the second type of F test, slightly more difficult, but actually not that difficult. So we run 2 regressions. For the second regression, we add more explanatory variables. So we want to know, is it really a good decision or an improvement to the goodness of fit of the regression by including additional explanatory variables? So there are certain things you need to know. The original regression, we call it the old regression. Then the new regression with additional explanatory variables, we call it the new regression. And then for the computed F stat, I need to enlarge the... Okay, I hope you can see the equation more clearly. The computed F statistic equation. Numerator, R squared of the new regression minus the R squared of the old regression divided by the number of additional explanatory variables added in the new regression. Denominator 1 minus the R squared. So keep in mind, the R squared comes from the new regressions. So make sure you substitute the right R squared. Divided by n minus the number of parameters, coming from which regression? Again, from the new regression, which contains the additional explanatory variables. And then I think for this type of F test, we want to reject the null hypothesis because we want to prove that we make the right decision to include the right and relevant, hopefully relevant, additional explanatory variables. So let me keep the equation here. And then we can do question 13. So let's look at the two regressions. First one, marks explained by study hours, party hours. So I already know this is my old regression. Let me just call it old regression. Second regression, you see I include 3 additional explanatory variables. Lecture attendance, I think it makes sense. Tutorial attendance, it also makes sense. Laptop dummy, it makes sense because who knows if students who own a laptop would perform better. Then again, I give you the N. K, I'm not supposed to give it to you, but you would quickly realize. 5 slope parameters plus the constant. So K should be equal to 6. For the first one, K should be equal to 3. And then I must give you the R squared of both regressions. So test if the 3 additional explanatory variables contribute to the regression at alpha equals 5%. You spot the keywords additional. So it must be the second type of F test, marginal contribution of additional explanatory variables. So let me copy the equation, put it here. Step 1, it should be fine. New hypothesis we want to reject. I don't want to see a situation that we make a silly decision to include the three additional explanatory variables, but they don't contribute. So we actually want to reject the new hypothesis. Alternative hypothesis is the new hypothesis is not true. Step 2, computed F status substitution, R squared of the new regression, 0.6987. Minus the R squared of the old regression, 0.5588 bracket, divided by the number of additional explanatory variables, 1, 2, and 3. So you put 3 here. And then divided by 1 minus the R squared of the new regression. This is why you must be careful. Substitute 0.6987. Divided by n minus k, 46. Which k? The k must come from the new regression, 6. And this is how you work out the computed F statistic, 6.1910. And then for the critical F stats, degrees of freedoms of numerator is 3, degrees of freedoms of denominator is 40. 3 and 40, alpha is 5%. I need to get rid of these. 3 and 40. So it is here, 3 and 40. Alpha is 5%. This is why we get 2.84. Yeah, 2.84. And since the computed F stat is greater than the critical F stat, good news. So the new hypothesis is rejected. So it means the alternative hypothesis will take place, meaning the 3 additional explanatory variables, that is, lecture attendance, tutorial attendance, and laptop dummy should all be included in the regression. Okay? So this is the second type of F test, which is still quite straightforward, actually. Okay, and then for the third type of F test, restricted least square, it means I want to impose some restriction on the slope parameter, maybe on one or more than one slope parameters, and we want to know if it is a wise decision to impose the restriction on the parameter. So you just need to be careful with the equation. It is here. Later in the next video, I will let you know how to distinguish the restricted from the unrestricted regression. Okay, and then M stands for the number of restrictions imposed in the restricted regression. Okay, so let me keep this computed F statistic equation. And then the K, look at the M minus K, the K must come from the unrestricted regression. So if you look at all the terms in the denominator, they must all come from the unrestricted regression. So let's take a short break, and then when we return, we would do question 15.